Hey guys, welcome back. So today I want to build another lab bench power supply. I already built one some time ago, but it's not really portable. It's split into power supply unit and voltage regulator unit, so this is only designed to stay on my bench. And today I want to build a new one that is also really beginner friendly. Everything we need is on here, except for the project box. This is the project box. I will put everything inside. And it's rather simple. I've bought a power supply module. This is a 24 volt 5 amp. No, it's a 24 volt 4 to 6 amp module. It can deliver 4 amps continuous and up to 6 amps. If you go for full 4 amps, you should definitely cool it actively. So I've got a fan. It's a small 14 volt DC fan. I've also got a small DC to DC converter to convert the 24 volt to 14 volts. Then I've got a volt and ammeter over here with its cables, a DC to DC converter with volt adjustment and current adjustment. I will replace these potentiometers with external ones so I can adjust the voltage more easily. I have some caps for these, and I will use 2 of these new terminals that I recently got. But this whole setup with this DC to DC converter, it can only output 5 amps, not more. So this is a really beginner-friendly thing. You just have to wire everything accordingly, and that's it. I will now proceed with preparing the fan, which gets its own DC to DC converter, and the main DC to DC converter, which is the heart of the lab bench power supply. So I was working on the DC to DC converter, and I installed the potentiometers, and something a bit weird happened. So the potentiometers that were originally installed were these multi-turn potentiometers that you adjust with a screwdriver. And I measured both of them for the voltage and current setting, and they were both 10 kilo ohms. So obviously I installed 10 kilo ohm potentiometers, these rotary ones. When I first tested the DC to DC converter, and really fast, I was hitting the maximum voltage I supplied to the DC to DC converter way before the actual potentiometer reached the other side, which shouldn't happen. For some reason they installed a 10 kilo ohm multi-turn potentiometer, but it only requires 5 kilo ohm. So to get the required resistance, I just bridged the outer contacts of the potentiometer with another 10 kilo ohm resistor. This results in an overall resistance of the potentiometer of 5 kilo ohms. Now, if I start at the low point, it's the minimum voltage the DC to DC converter has to supply. And now I can turn all the way to the other side, to the next stop of the potentiometer, and then I hit the maximum voltage the DC to DC converter can supply. Now, this means that starting from the left, I supply the lowest voltage the DC to DC converter can supply, and turning all the way to the right, it supplies the maximum voltage. This also results in a higher precision if I want to hit a certain voltage. Now let me demonstrate. I will turn down the potentiometer to a low voltage. This is the minimum voltage it can supply, or it has to supply. And then when I turn up all the way to the right, I exactly hit the voltage I'm currently supplying minus a tiny amount, a few hundred millivolts. I am supplying 24 volts, and this is 23.56 volts. And if I want to go to 12 volts, I can do so much more reliable and precise. Like this. Beforehand, this tiny amount like this would have resulted in over 1 volt of change. Now it's much more subtle and easier to hit the target voltage. Now I'm done with all the preparation needed and I can proceed with the assembly. But first let me show you how everything will go together. So this is the top part of the project box I'm using. And this arrangement allows me to, in the future, install the exact same power supply that I will install now into the project box one more time. So we have the main switch over here. So this will go in like this. We have the volt and ammeter over here that will go into this cutout. Here are 2 holes for the potentiometers of the DC to DC converter. And I've got, where are they? Where are my banana plugs? Or the jacks? Here. So these will go in here. Just like that. So in the future, I will mirror this setup to the other side and have a second power supply in the same project box. This allows me to either have a higher overall current, reach a higher voltage by connecting them in series, more current connecting them in parallel, or supplying 2 different voltages to projects. And the inside is also prepared for 2 of these power supplies. I've got 4 standoffs in here. The first power supply will go in like this. I've got a DC fan with a DC to DC converter that will directly be supplied by this power supply. If I have another power supply inside, each power supply will be switched on by this main switch. I will have another one over here for the right side. One of these has to be powered on and the fan starts to spin. It will suck air in from the side, out the other side, where also the IC socket is located at. Now, the heat sinks of these power supplies are mounted and meant to be supplied with air from the top. So I had to come up with a solution to enhance cooling and also safety, so I made this. This is a shroud from thick paper, or rather cardboard. and it will go over the power supply. Now this looks a bit funny, but everything has a reason. So this goes over here. The DC to DC converter will be stuck down like this. I changed the direction of this heatsink. Now air flowing over it will go through the channels, or rather a few of them, and the top part of all of the channels, and cool the DC to DC converter. So we have the inside over here, the outside over here, and I then have to connect everything accordingly, which I will show you later. So the air will come in like this and be redirected downwards into the heatsink channels for both heatsinks. And these cutouts are made to account for cabling. For example, these cables, they have to go like this, and they stick down exactly here, where otherwise the shroud would be. So I had to make this cutout. Same goes for the lower left banana jack. The mains voltage comes in from here, and then will come up from the middle into the main switch, and from the main switch directly into the power supply. And I hope I didn't miss anything. If I did, hopefully I will figure that out after I'm done. And this is how it looks for now, till I install the second power supply. All the primary side cables are still way too long, and I have to shorten also the cables that go to the banana jacks. But let me explain to you how everything is wired. So we have the IEC socket, we have live and neutral coming in to the switch on the top. From the switch it goes then down into the power supply underneath here. Then we have positive and negative coming out of the power supply, 24 volts, going directly into this DC to DC converter, which adjusts the voltage from 1.25 volts up to 28, but it's just a buck converter, so the outgoing voltage is always lower or same as the ingoing voltage. And on the inside of the DC to DC converter, I also connected power for the volt and ammeter and power for the other DC to DC converter, which will further adjust the voltage, the 24 volt, regulate it down to like 12 volt for our small fan over here. Then we have the two 3-pin connectors going to the potentiometers for voltage and current adjustment. And we have these cables on the secondary side of our DC to DC converter. Red goes directly to positive, and I also connected the yellow cable, which will indicate the voltage from the volt and ammeter, and the black cable goes into this 2-pin connector on the volt and ammeter, and here will be the current measurement. And then we have the red going out into the negative pole. So this is just how it's wired. You have to have the negative going into the volt and ammeter and the red going out into your banana jack. Now I've closed everything up and made this test arrangement. I've got my multimeter connected to the output of the bench power supply, and the mains cable is connected to my safety outlet over here. And now let's see if everything works how it should. Okay, the light is turned on immediately, so I might have to swap the connections, but it's not a big deal. And now let's turn it on. Turns on, no problem. Fan spinning, sucking in air over here and extracting air over here. Works just fine. Now let's see. That works. It's approximately 200 millivolts off, but we can easily adjust the volt and ammeter. It has a potentiometer on the backside for voltage adjustment, so that's not a big deal. I can do that later. Let's go up. Dial in at 12 volts. That works. And go all the way up to 23.56 volts. Now let's see and actually power something. I've got some LED strips. How about this? 5-meter LED strip. Grab the leads. It's turned all the way down, so it will not burn immediately. Now this is connected. And let's see, I will separate them. Turn it on. 1.1. Let's go up to 9 volts. Oh, it doesn't turn further up. I have to adjust the current. Let me turn it up like this and go to 12 volts. Okay, that's 12 volts at 5.2 amps. Now let's limit the current. There we go. It's a bit mushy. And it seems, yeah, definitely, the potentiometer for current also needs a 10 kilo ohm resistor in parallel to get down to 5 kilo ohms. Then I would be able to adjust current over the whole range and not only like a third of its range. But that is not a big deal, just need to install another resistor. And this fan is for 14 volts, and I've currently set it at 12 volts, and we have plenty of airflow. I might dial it back to maybe 9 volts. Maybe I'll dial it back, maybe I'll let it sit at 12 volts. It doesn't really matter. Okay, so before I end the video, and thanks for watching so far, I want to show you something that I completely forgot. You can argue about that if it's necessary or not, but I think it is, and that is to connect the metal meshes from both sides to protective earth. I don't feel comfortable having metal exposed on the outside that is not connected to protective earth. If something goes wrong, this could be deadly. It's unlikely, but better be safe than sorry. And while I was at this, I also added in a resistor for the current potentiometer, and now everything works just fine. So I hope you liked the video, and if you did, please leave a like. Thanks for watching, and I hope to see you next time. Bye!